Bismillahirrahmanirrahim. Assalamu alaikum dear viewers, I am Dr. Noshin Afshan and you are watching Dr. Noshin Afshan YouTube. I hope that you are enjoying your well-being and I am thankful to you for watching this video. To watch more videos, please subscribe my channel and press bell icon. So now let's begin. As we are discussing about the reactions of pyridine, so in today's lecture we will see the reactions of pyridine with oxidizing agents, then with nucleophilic reagents via hydride transfer, and with respect to alkylation, arylation, amination and displacement of good living group. So in the previous lectures we have studied the electrophilic addition reactions at nitrogen of pyridine and electrophilic substitution reactions at carbon of pyridine. And now in this lecture we will study the reactions of pyridine with oxidizing agents. First of all, the pyridine ring is highly resistant to oxidizing agents. So what is the oxidizing agent? For example, any oxidizing agent that oxidizes any alkyl side chain is known as oxidizing agent, and this pyridine molecule is highly resistant towards oxidizing agents, but vigorous conditions may be required for its breakdown or for its oxidation. For example, here oxygen at 4 atmosphere with tertiary butoxide salt of potassium under DMF. So under these conditions pyridine reacts, here it is methyl group or methyl side chain of the pyridine, and under these conditions 3-methyl pyridine would be turned into pyridine 3-carboxylic acid. And the other example is, in case there are 2 alkyl groups attached with the pyridine ring and the chain length differs. For example, here is methyl group and here is ethyl group. So among these 2 groups, which one would be oxidized? The alkyl groups whose chain length is smaller as compared to the other substituent or other alkyl group would be oxidized into carboxylic acid. So in this case the reagent is selenium oxide and pyridine at 110 degrees Celsius, and the ethyl substituent would be intact, would be as it is, and here at this 3 position it would be turned as COOH. It would be converted into, oh sorry, it is not at 3 position, rather it is at 2 position. For the inconvenience of the space over here, I have drawn it in this direction, but actually it is symmetrically in this position. So don't be confused about its position. Actually it would be pointed symmetrically along this direction. So here it is COOH and this methyl group is oxidized into this carboxylic acid group and the ethyl has been intact. It has not been oxidized. So our next type of reactions is nucleophilic substitution reactions of pyridine via hydride transfer. So the category of nucleophilic substitution reactions is via hydride transfer. This is nucleophilic substitution reactions via hydride transfer, and the first one in this category is alkylation and arylation. Let's see its example over here. Here it is attached with n-butyl group, and again it reacts with lithium and butyl at 100 degrees Celsius, and it would be turned into an intermediate, that is this n-butyl group would be written as it is. And here see, this lithium is in plus oxidation plus with plus charge, and this butyl, the terminal alkyl group of this butyl would be carbanion form. This positive would be attracted towards the nitrogen lone pair, and it would be written here with nitrogen, and the second n-butyl group would be turned here, and this is actually an intermediate. After this group or this bond pair would be turned over here, and the hydride would be eliminated, and our product with the elimination of lithium hydride would look like this. Again, n-butyl group. So this n-butyl points towards the alkylation of pyridine. Now let's see the arylation of pyridine. This is lithium, phenyl lithium. Again, the lithium would be attached with nitrogen, and sorry, it is not, orientation of the double bond is not like this, rather it would be like this, and in this case there would be only 3 bonds of nitrogen, and the positive charge would not be on nitrogen. And here it is H, and pH would be here, and again it would again react with oxygen or methylbenzene at 100 degrees Celsius, and the product would be here it is phenyl group. So this 2-phenylpyridine would be our final product. And in the previous example, if I have not written that intermediate, in the case of alkylation, the intermediate would be like this one. The lithium would be here, the n-butyl is like this, and again H and n-butyl. So this was the intermediate in the case of previous example, that is alkylation of pyridine, and then this would go here and it would be eliminated like this. And the other example is Here it is a two-step procedure. In the first, we will treat pyridine with N-butyl, with lithium N-butyl, and THF, that is tetrahydrofuran, at minus 20 degrees Celsius. And in the second step, we will react it with BOC and double bond and BOC with again THF, as it is in the reaction medium, at minus 78 degrees Celsius. So what is this Boc N? Actually, it is called as di-tertiary butyl. This is tertiary butyl group, or in the other way we may write it like this. This is tertiary butyl group. This is carboxylate, and it is azo, like this. So Boc is actually di-tertiary butyl azo dicarboxylate, and in this way the azo group is like this: tertiary butyl, this tertiary butyl, and it is in di form, so again, and dicarboxylate. So this one carboxylate, and here there is another carboxylate group, and one other tertiary butyl group. So in this way, this is di-tertiary butyl, this is one butyl, and this is the second butyl group. So in this way, this is di-tertiary butyl, then azo, and then dicarboxylate. So one carboxylate and the second carboxylate. In this way, we may say it di-tertiary butyl azo dicarboxylate, that is Boc. Butyl for B, and azo dicarboxylate for OC, and azo for N double bond N. So the abbreviated form would be written over here. And in this way, our intermediate would be like this. Again, lithium would come over here, and the double bonds would become at this position, and here it would be H and N butyl, and this is our intermediate stage. So now what happens, actually the bond pair between nitrogen and lithium would be shifted over here, and this double bond would attack on nitrogen. When it would attack on nitrogen, then this double bond would shift towards nitrogen, and it would become in this stage. Here this position would be attached with this nitrogen, and again it is attached with BOC, and here on the other side this is nitrogen with negative charge, because this bond pair would be shifted on nitrogen in the form of this negative charge, and again it is attached with Boc. And then this reacts with oxygen, and we get our final product in this final form, here it would be just N-butyl, and at this position this nitrogen would be attached with POC, and along this side it is attached with nitrogen, hydrogen. With one hydrogen, this would abstract one hydrogen as well. And as one hydrogen is here, so it is understood that one hydrogen is also here, or you may write it along this way, and this would be abstracted by this one. This would be shifted over here and this would be shifted over here. Or it is not be shifted along this direction, rather it would be shifted to this position and it would be shifted along this, and this hydride would be eliminated. And in this case here this hydrogen would be attached with this nitrogen, and again the Boc would be attached with nitrogen. So this is our final product in this case. And here there is another point, that in the case of two substituted lithium derivatives, of pyridine may react with electrophiles via use of that NN-Boc. So in the previous examples we have seen the one substituted lithium derivatives of pyridine have reacted with electrophilic reagent via this route, but the two substituted lithium derivatives of pyridine also react in the same way via this compound. So the next is amination. Amination of pyridines and related heterocycles generally at a position alpha or at position alpha only to the nitrogen is known as Chichibabin reaction. So basically this is the pyridine and this is alpha position of pyridine. So if the amination occurs at this alpha position of this pyridine or any other or related heterocycles, then this is known as Chichibabin reaction. And in this case it actually reacts with sodamide with the elimination of hydrogen with minus H2. So let's see the example over here. It reacts with sodamide under phenyl dimethyl phenylamine at 100 degrees Celsius, and the intermediate looks like this. Here this hydrogen would be here and this amide group would become here, and again there is another group where this position is like this with NH2. So in this case, this hydrogen would make the new bond pair with this hydrogen, and this hydrogen would give its bond pair to the nitrogen, and we will get, and this is actually an intermediate stage, and here this hydrogen and this hydrogen would make a bond in between them, and they would be eliminated in the form of minus H2, and our final product would be with sodium ion plus here the second product is with this NH2. If we see here, this with NH2 only would become here in this way, and the other product with negative charge and sodium would go over here, and one proton would become attached with this nitrogen, and in this case we will have the two products. So that's it. Thank you very much for watching the video, and stay tuned. Please subscribe my channel and press bell icon to watch more videos. Allah Hafiz.